Hello guys, today we are talking about implementation of linear regression model. It is a very important algorithm as well as very basic algorithm in the field of machine learning. So without any further delay, we move in the implementation part where I explain each and everything in detail by implementing in the notebook. So I use Jupyter notebook. You can also use Google Colab. So first, I import important libraries such as pandas, numpy, matplotlib. Matplotlib is used for showing the graph, like thing, for example, bar graph, etc. Numpy is used for calculation, numerical calculation, and pandas is used to show the data set. So I run this cell. After that, I load the data set. I provide the data set in the description below as well as whole notebook you can find in the description box. So I run this. After that, we need to find the shape of our data set. So I also run this. So by this we get that our data set is 25 rows and 2 columns. So dataset dot head is used to show the top 5 entry of our dataset. If we want 10 entry, so we just simply put 10. By default it show 5. If we want 10, 1, 2 any, so we put this number and run this cell. So we got 10 entries. Then we describe our dataset at how many mean of all this, count, standard deviation 25%, all this by using dataset.describe. So we get that count is 25, that we also get from here. Mean means total upon divide number of item, so we get the mean. Standard deviation, minimum, we get minimum is 1.1 hour in whole data set, 25% 20, and maximum is 9.2 in the whole data set. After that, we plot the graph. Hours here in the axis we take hours studies, that how many hours the child or a student study, or how by studying this hour how many percentage he or she get. So by this we run this and we enter O. So that's its shape is a circle, and plot title is hours per percentage, that we get from here, that we get here. Hours studies, R studies, percentage, and data set dot plot. X axis we take hours, Y is scores. So we get this, and then we divide our dataset into independent as well as dependent dataset. For this, in our dataset, this hours field are independent because it is not dependent on any, but score are dependent because it depend on the hours of study the child or the student can do. So scores are dependent field on hours, but hours are independent field. So column means dash, column dash means take all the columns, and -1 means take every all rows, sorry, take all rows, comma, -1 means leave, take all the column except last column. So by this -1 we take all this row and column but leave -1, that is the last score. And by y dataset dot ilog means dependent, तो अपना डिपेंडेंट सिर्फ स्कोर्स पे ही है. तो take all the rows and comma 1, that is only the score field. I run this cell. Then after that, sklearn dot model selection import train test split means we divide our dataset into train as well as testing. from x comma y that we get from here. Test size is 0.2, means out of 100, 20% data is for test and 80% is data for train. So by 0. If you want 15%, so put 0.15, or 30% 0.3. It is totally dependent on you, but the officially we most in the case we take 0.2, that is 20%. Then we apply the linear regression algorithm from sklearn.linear model linear regression, and the regressor is linear regression. Regressor dot fit s train y train, that is we get from here. By this we train our data set using linear regression model. Then if we want to regressor dot intercept, regressor dot intercept means in linear case we get the equation y equals to mx plus c, where x and y are here, and we need to find regressor intercept, means y equals to mx plus c, we need to find c. So this is called c, regressor dot intercept. So we get 2.018 of regressor dot coefficient, means y equals to mx, so it is m. We also save m, so m is 9.91. so y here, y equals to m here, x here plus c. So by this we get the, then y predict, regressor dot predict as test, means y equals to mx, regressor dot predict mx. Then bd actual y test predicted, means we print actual as well as predicted. So actual data set, actual value that we get is 20, and predict is around 17, 27, 33, 69, 75. The result is not looking good, but that's why linear regression, in most of the case we don't use linear regression, because it not give the exact, means minimum error result. We use mostly various advanced level algorithms such as random forest or a gradient boosting, but this algorithm we also know, I have an idea about this algorithm, so I just perform this. Then okay, I don't forgot to run this, then I get this. And then we need to find mean square error, mean absolute error, or root mean. Mean absolute error is just simply total upon total number of sum divided by total number of means data we have. Mean square error is square of the error, and root mean square by after squaring apply the root also. So we get all this from here. Thank you for watching. If you have any doubt or a query, you can just comment down in the comment box. I will try to reply as soon as possible. Thank you once again. Thank you.